Well, good afternoon, Chem 1. It's Thursday. Welcome to my basement. Sorry for cutting from the video right now. But I got this set up. I wanted to show you the next chapter. And we're going to barely cover the information. There's a lot of good stuff in there. We're just going to kind of skim the surface. And the main thing we're looking at in this chapter is matter. And matter can be broken into two main areas. First is pure substance. And first one of that is an element. Elements are what's on the periodic table. And the only thing I had in hand is aluminum, so aluminum foil. So this is an example of an element. Yeah, I decided not to show you all my supplies of silver and gold, right, sitting around the house. Yeah. Anyhow, so this is an example of an element. By the way, if you're noticing this sculpture in the back, you may have seen it in the other video. When my son was in high school and early college, he made all kinds of sculptures, really got pretty good at it. Anyhow, we got quite a few of these things sitting around the house. Okay, a compound would be, this is sugar. Okay, I just grab some sugar and put in this beaker, or not a beaker, but this, we got a lot of jelly jars in our house. So this is an example of a compound. Now, a lot of things are compounds. Sodium chloride is a compound. You know, anything can be a compound. This is sugar, C12H22O11. I mean, there's just numerous things in our lives that are compounds. Okay, a mixture. It can be homogeneous. Homogeneous would be like this milk. This milk is a colloid. A colloid has particle sizes in it that are decent size, but yet if I try to shine a light through there, it's going to hard to get through. Now I can spin this down a centrifuge. I can pull all the fat out of it. Basically, you get tiny fat particles in water is what milk is. And so this being an example of colloid, very uniform in its distribution, very smooth in that regard. I'm going to jump over here to heterogeneous. Typically that'd be a suspension. So like if I take sand, that's all this is sand, and I put some water in there, and then I don't have a stirring rod at home, imagine that, but I can stir this, and I get a suspension. The particles are now mixed up. If you've gone by a river after a rain and seen it's all high and muddy, okay, you got a suspension going on. Now what eventually happens? Well, eventually happens, it goes back down. Okay, the particles settle back out. Right now, growth stop, but we're all shedding skin cells. We're shedding particles off our clothing. Those are floating in the air as dust. Eventually they settle out. It's a suspension. And so we dust our furniture. Now if I let that sit long enough, eventually that'll even settle down even more. But that'd be an example of, again, of a suspension. If you have a salad dressing, you have to shake up before you use it. Oil and water, you can mix that together. Oil and water. Oil is an organic molecule. Water is a polar covalent molecule. They don't mix together. You shake them, you can force them together, but they'll separate out. Now, if you want to force them together completely, you make what's called an emulsion. To do that, you need an emulsifying agent. And eggs are an excellent emulsifying agent. If you ever use mayonnaise, that's just oil and water held together. Throw some oil and water in a blender and egg white, whip it up, you've got your own mayonnaise. May want to get some permission before you try that. Okay, I wanted to come back because here's where I want to spend our time is under solutions. That's the main thing I wanted to get out of this chapter. These are all good definitions. You're going to see them on your test, so keep that in mind. But a suspension, a solution, what it has here, these have very large particle sizes. You can see they start settling out. Again, this is just sand and water. Some of the smaller particle sizes are still starting to settle down. You almost see a gradient in here. Dark at the bottom, kind of getting lighter towards the top. A colloid has much smaller particle size than a suspension, but yet they're still decent size. In a solution, if I put some water here into this sugar, and I didn't measure it out ahead of time, I just grabbed some from upstairs and stir it around, then I get a solution. What that means is all the particles, and I may have put too much stuff in there, and that's okay. Then pour it over here so you can see a little easier. That beaker or that jar is a little cleaner. And so now I have sugar dissolved in this water. If I taste that, it tastes very sweet to me and to you. Okay, a couple terms that to look at. Solute is, and I'll just write this here, the thing, gotta be careful, don't knock my board over, dissolved. And a solvent is the dissolving thing. So to say the thing dissolving. A great example of solvent is water. You may have heard of a term called universal solvent. That's because so many things will dissolve in water. So it's used in a lot of things we buy. A, it's free, but B, it's such a good solvent. So a lot of things will dissolve in it. If your parents have painted the house, okay, they can buy two types of paint. One is a water-based, which means that the particles will dissolve in water, a lot easier to clean up. Then there's oil-based. The particles all dissolve in the organic phase in the oil. Much harder to clean up. You can't clean it up with soap and water real easily. Soap, for example, has two ends to it. Has an end that is attracted to oil and ends attracted to water. And that's why it's able to remove dirt and grime from your hands. So this would be an example of a solution. In a solution, the particle sizes are tiny. If I try to pour this through a filter, it passed right on through. This, most of it would, although like I say, you put this in a centrifuge, you can get all the fat out of there. This you put in the centrifuge, nothing's going to happen. This eventually with time, and you need to see now more, just in the last minute or two, more settling. So those are our main terms. Those are the terms that's going to be on the test in the multiple choice fashion. There's also going to be some pictures of things that you can see on that worksheet that's on there. And I'll try to explain more on the actual Canvas assignment. But this in a nutshell is what we're after in this particular unit. So you have, again, an element, compound, colloid, suspension, and a solution with the solute and the solvent. Whichever you have less of is a solute. More of is a solvent. For example, I'm breathing right now. So are you. We're breathing air. Air is a solution. Well, what's the solvent? Nitrogen, because there's more of it. What's a solute? Well, oxygen. There's also some carbon dioxide and there's some argon, all dissolved in it. It's very uniform in its distribution, just like this is. Okay, very homogeneous. We want to make sure if I breathe air here or over there or some other place, it's all the same. So that makes it valid as well. So I hope this helps explain these terms. I'm going to give you another video. I don't know if I get a chance to make it yet today. My wife is down here for her job here in a few minutes. Her office is right behind me. But it's going to be a little bit more on on solutions and how we can calculate those, because that's also going to be on the test. And that's probably the most important thing we're going to pull out of this particular unit. So again, I hope your day is going well, and we'll check in later.